There we go.
Okay.
So our next presentation is Colin Rundel. Colin is a professor at Duke University, and he's going to talk to us about teaching statistical computing with Git and GitHub. Thanks very much, Colin.
Great. Thank you so much for having me, and thank you all for being here. It's great following Debbie's talks. I'm going to hit on a lot of the same themes and a lot of the same tools and some of those ideas, and talk about it sort of in my particular case, sort of what I've developed over time, how we do stuff using Git and GitHub, and sort of particularly from the instructor's perspective. So what do I, as an instructor for these kind of courses, get out of it? What does it let me do, and that kind of thing. So that's going to be what I'm going to sort of hopefully talk about over the next 25 minutes or so. So a little bit of context. So I'm an assistant professor of the practice here at Duke in the Department of Statistical Science. For the last 7-8 years, one of the major focuses of my teaching has been on statistical computing. So these 523 and 323 are master's and undergraduate level statistical computing courses that have been sort of a major place for us to develop some of these workflows around doing collaborative computing work, doing reproducible computing work, and training new students at both of those levels with these sort of core skill sets. More recently, just this year, I've started teaching the Stat 663 class, which is the same thing, but now in Python. The other two courses are primarily focused on R. And then also occasionally I get the chance to teach something a little bit more statistical modeling, so doing things in like spatiotemporal modeling, that kind of stuff. All of the tools and the stuff that I'm going to talk about today apply across all of these courses. They've primarily been developed in the computing courses because they're most relevant there, but they even apply for the more traditional statistical courses because even something like that involves some level of computing. We need to fit models, we need to run code and that kind of thing. So we want to do that in a reproducible fashion. So we've been able to leverage a lot of the same stuff there. So because these are the courses I've been teaching, a lot of my then work has been around developing tools that make this kind of thing possible, that enable stuff in the context of working on GitHub, collaborating on GitHub, making my own life as an instructor easier to automate these processes, and then also thinking about how I scale some of these tools. So when we first taught 323, it was about 20 or 30 students. Now it's regularly 50 students. The undergraduate version is now 70 or 80 students. So things that were possible with manual intervention once upon a time are not anymore. And so we need to think about how we do all of that kind of stuff. And so the 3 packages that are listed on the left are all R packages that I've been working on recently. GH class and Parse Rmd are on CRAN. Checklist is not, but should be soon. I have other things that are out there, but these are the ones that I'm particularly going to touch on today as we go through some examples about all of this stuff. So I'm going to give you some context about how all of this works, what my workflow looks like, and why we're choosing to do all of these things in this particular way. And some of the stuff that's been developed in these particular courses is now spread out more across the curriculum. So now we're doing Git and GitHub in our introductory classes and in our regression class and in our senior theses and all that kind of thing. So it's paid a huge dividend across the entire curriculum of the department in a very nice way. So in terms of the approach we take in terms of instructing and teaching reproducibility, it's really sort of a 3-legged stool in terms of building up the core tools. Basically, any sort of workflow that we're going to use or take into account is going to need each of these 3 components. And so in particular, like the choices are somewhat arbitrary, but they shouldn't be terribly surprising for this audience. So scriptability is just when you're expressing what you've done, it needs to be written down in a way that keeps track of things. Modifications to data in Excel are not tracked, versus if you write code to do data munging in R, that is inherently documented in some fashion. So using some kind of programming language as opposed to a graphical user interface to do your analysis. We're big proponents of literate programming. So Debbie did a really nice introduction to R Markdown. There are other options out there with like Jupyter Notebooks, those kinds of things. And again, that kind of coupling of the code with the narrative is an incredibly powerful paradigm to create really rich documents, but also much more reproducible documents, because all the information is in one place. I'll touch on Quarto a little bit, and then you'll get even more in the next talk when Mina talks about Quarto a little bit more, but that's a new publishing tool from our studio that tries to tie all of these things together in a really nice way. That's quite nice. And then finally, we also need to track changes over time. We need version control. So at the heart of this talk, we're going to talk about using Git and GitHub. Any of these things could be swapped out, but I think at this particular time point, this particular combination of these tools is incredibly powerful and a very rich vein to mine for a lot of utility in terms of teaching these kinds of things. That's not to say it will be the same in 5 years or 10 years, but this is the kind of thing we just have to keep modifying and updating as the tools become available. But they're particularly better now than they've ever been in the past. And it's a great time to work on this kind of thing and give these tools to students because they are much more approachable than they've ever been. A couple other things. So my basic approach is that for my courses, I use GitHub as more or less my learning management system. Everything on the course goes onto GitHub. The course website is on GitHub. It gets built into a GitHub page. That's where all the schedules and everything are linked. All the slides are RMD documents. They get rendered to HTML, goes on the website. All of the assignments live there. So we do an approach where students are invited to the organization. Those memberships are private, so we're not disclosing any confidential information. We're not running afoul of FERPA or anything else like that. And then all of their assignments then are created as repositories there. So for each assignment, for each team or each individual, we create a separate repository. We use a very sort of structured naming scheme so we can keep all of them straight. So common prefixes for homework 01. All of the assignments for that particular assignment have that same prefix, makes it very easy to find things, makes it very easy to automate processes to work with those kinds of things. There's sort of the carrot and the stick aspect of getting students to use GitHub, and getting that buy-in is challenging. In this case, this is very much the eat your broccoli kind of approach where they don't have a choice. All of their work needs to be completed on GitHub. It needs to be turned in on GitHub. They have to use it. They have to engage with the tools in order to turn in their assignments. And as an instructor, that also makes it a lot easier for everything to be consistent in some fashion for me to grab it and that kind of stuff. We also do collaboration and other kinds of things, but we also do the direct feedback to students. So not numeric grades, but all the commentary and everything else is done via issues. And that also promotes sort of a back and forth potentially where the students can then reply and ask questions and we can give them feedback, and it persists. And I'm not answering one person's question, but their entire team can see that feedback and they can have a discussion there and that kind of thing. So leveraging some of the other tools that are then built on top of the GitHub system. Why GitHub? Basically, we're buying in there because of the ecosystem. It is sort of the definitive tool that's out there, but also because so much effort has gone into making it a powerful place to work with things. I'll talk a little bit about the GH class package that Debbie mentioned that I developed. All of that is about automation of interactions with GitHub to avoid manual steps. And all of that is done via the API. The API on GitHub is incredibly rich. You can do all sorts of things. It's really, really powerful. And everything in that package is mediated through that API. I know some people use GitLab. That's great. When I've looked at that, you can do some of the things with their API, but not quite as much. And that's been a major sort of stumbling block for us in terms of not being able to do everything that we would want in that particular ecosystem. As an instructor, another thing that I find really powerful about GitHub and Git is we do lots of teamwork, team assignments, and inherently with using a version control system, we have accountability via things like commit histories. So I can take a look about who committed when, who added what. It's not a perfect system, but it's way more insight into a completed assignment than I would normally get when I just get the final product. So I can see who did what when, I can assess if there's problems, I can intervene early and all sorts of things, and I'll show you some examples of that down the road. Collaboration is another big thing. Yes, merge conflicts are painful. Google Docs would be nice, but again, it is a system that does work for collaboration, and it does so in a distributed fashion where they can all work independently and then bring things together. It's really interesting to see what sort of emergent behaviors come from that in terms of how they avoid merge conflicts and the rest. But fundamentally, it does work, and they get better at it over the course of a semester, and particularly over multiple semesters and multiple courses. Scalability, the courses I'm talking about today are mostly in the 40 to 80 range. I've also done this in courses that are 200 plus students, and that would not be possible without a lot of this tooling around this kind of stuff. And the other thing is this relevance beyond the classroom. I want to teach tools that are not going to be just a one-off, that I don't want to spend time teaching something you're never going to use outside of the classroom. So the kind of buy-in of it's a professional tool that is useful, whether you're going into industry or going on to a PhD or anything like that, as well as it's a very useful place to put your work so that people can find you and give you an internship or get a job and that kind of thing. So getting that buy-in is very useful, but I think there's a learning curve, but you can get that by convincing students that it's worthwhile in the greater scheme of things. Okay, so how do we then use this in practice? So everything for all of these courses is repository based. So the example here, I'm just showing you a screenshot of one of the homework assignments for my undergraduate computing course this semester. Since everything is repository based, that's what we put together. So for an assignment, we will give them a README file that has all of the instructions, everything they need to do, the deadlines, the rules, anything else like that. We will give them a templated RMD like Debbie was showing in the last talk that gives you some structure, tells them where to put answers in, that kind of thing. Early assignments are very heavily templated. Later assignments are much more loosely templated in terms of what we give them and what we ask of them as it goes. And then we give them some other kind of scaffolding stuff. So if I want to put an image in the plot, an R project file, git ignore, and the rest of that kind of thing. But the point is, it's just files, but it's not one file. So I can make things a little bit more organized and spread them out as opposed to trying to put, here's the one document that I'm going to put up on the learning management system for you to download. It's all versioned. So I have I can make changes to it. I can bring it in easily from the previous years and make modifications and all of the rest, but it is just files. So that's a really nice way of working with things. And then leveraging the version control kind of changes over time. What this looks like to the students is something like this. So this is the content of the homework1.rmd. And just again, showing you examples of what that templating looks like. So we give them some basic YAML and say, look, you're working in a team, put your name where the teammates are so we can see who it is. Include instructions. I do have to say, the most common mistake my students make is I tend to put the instructions as an HTML comment so it doesn't show up in the final document. They will write their entire write-up there in that comment, and then it won't show in the rendered document, trying to convince them that that's a bad idea. There's always one or two teams that do that. I don't quite understand why. But the point is that we can provide instructions to them to tell them what to do that said, okay, your solution for this needs to go in this particular part. And then things like providing scaffolded code. So in this case, they're doing the FizzBuzz kind of simple programming task. So here's the signature of the function. You're just going to add the code. So that way I'm going to have some uniformity of the answer. I'm sure that always the function is going to look the same way. It's going to have the same input argument, the same kind of thing. And we can provide testing code and the rest of that kind of stuff as it goes. Question, can you just take the instruction out of the comment? Yes, absolutely. And that's probably the better solution, which I've started to do a little bit. It just bothers me. I don't know why. I don't like them showing up there. So it's a personal hang up of my own, but it's one of these kinds of things where you do need to be careful about the instructions you give, and students will do interesting things that you don't necessarily expect. Nothing survives contact with the real world, as it were. So yeah, basically this is what a homework assignment looks like. I haven't showed you the README, but you can take a look. It's essentially just instructions. It says, here's the task, here's what you need to do, use written in Markdown to give them all of the instructions. And I like to separate that from the actual homework assignment because it makes my life easier when I'm grading, because I don't have to wade through all of that placeholder text and instructions and stuff. I can get to right to the bits of, this is what I need to grade, this is what I need to evaluate. So I wrote this package GH class basically because the first time I taught one of these courses, I did everything by hand. So every single time I was creating repositories for the students, I would create a new one, I would copy it over and do the rest. For a small class, you can do that. It was an hour or two a week, but that gets old really quickly. And so in the constant sort of fashion of, instead of doing it an hour a week, I will spend tens and tens of hours to write software that will solve that for me. But in the long run, this has paid off. And so the package basically provides a bunch of automation tools to interface with the API to do things automatically for you. And so particularly for instructors, probably the most important sort of function is this org create assignment. So all of the functions in the package have a prefix that tells you what it operates on. So in this case, I have an organization for my class. I'm going to create an assignment for that, and I'm going to pass in some various arguments in terms of what is the organization that I'm using. In this case, roster is just a data frame that has the students' GitHub usernames, and then the name of the repository that they're assigned to, and I'm using that same repository name as the team name that they will be put into. So in this case, this is a team-based assignment. And then I can provide a template repository. So in this case, this is that original repository I put together. I put all my files in. This will now be freshly copied for each of the students as we go through. It turns out that there's actually a number of steps that are necessary to create one of these things. And so all of this is sort of happening behind the scenes. So we're copying that template repository to the new repositories with the different names. We're then creating the student teams. We're adding the users to those teams. And then we're giving those teams the appropriate permissions to that repository. But the point is that once this infrastructure is set up, it becomes very easy to sort of in one fell swoop to run this, and I can create 20 repository assignments or 200 repository assignments in the matter of a couple minutes once I have sort of the proper setup in place. That's great. We can distribute things. This is something that you can also do with GitHub Classrooms. One of actually the driving reasons for the creation of this was I don't like how GitHub Classrooms does teams. That's because the students have to select the team that they belong to, which is an error-prone process. And I would always have to go in and clean it up afterwards. This is a process where I'm assigning the students to a team, and I actually do random assignment on everything. For every assignment has random assignment to teams, and then we mix it up for each assignment, and that sort of mixes the students and they meet each other and that kind of thing. This can also be used for individual-based assignments. If you just leave off that team argument, it will create individual assignments, give individual users access to those repositories, so you can use it for either thing. So that's fine, but again, there's alternative solutions. Where I think there's a really powerful tool here that I leverage all the time, or maybe I'm just error prone, is because we're working with Git repositories, everything is changeable, and I can make changes after I've distributed an assignment without worrying about causing too much harm to the students. Again, I'm going to try to generally avoid making modifications to that homework1.rmd because that will be divergent in terms of what students have put where. But if I need to change the instructions, if I wrote the wrong due date on it, or I give an extension to the class, it's nice to be able to go in and do that without having to send an email saying, disregard what it says there, this is the real version of that kind of thing. If I need to modify a data set or do anything else. And so all of this is just Git repositories. They all just live on GitHub, so that I can interface with that. And I can make changes in an automated fashion across the board. So this is just an example of another function that modifies an existing file. So this is going into readme.md. And in this case, maybe I forgot to change the due date from the last time I had this assigned. So it's just looking for a pattern. I'm giving it a replacement set of strings, and this will then go through for every single repository and make that modification. I can similarly add files or modify files, do any of those kinds of things to make those changes. And once you have that, it's actually kind of a freeing thing to know that, yes, I should have the assignment as ready as possible at the end, but if I need to make a correction or I need to make a change, I can, and I can do that in a very efficient manner as opposed to worrying about it after the fact. This does cause issues because now students will have to pull and there's maybe merge conflicts, but again, it's all part of the Git ecosystem. It's all things that they should engage with and learn how to do in the greater scheme of things. So I think that's definitely a killer feature in terms of all of this stuff. And if you wanted to use GitHub Classroom for the distribution, GH class will still let you do all of these kind of modifications secondarily to that. So you don't have to do an either or kind of thing. It's totally up to you in terms of what you want to use. Okay. Assessing participation, again, because we can interface with the API, we can get all sorts of rich information. This is available via Git and Git log and other kinds of stuff, but the API makes it quite nice to access. And so again, similarly, we just wrap that in a function in the package. So in this case, I'm using this GH class repo contributors. I'm pulling in a list of all of the homework 01 repositories. And so this is actually from my current class. All that I've done is just anonymize the student usernames compared to what they actually are. And then we can take a look at it. So I can see for the lab 1, team 1, everybody committed at least once. That's a good thing to see. Maybe I'm a little bit worried about Anya or Diego because they're not committing as much, but it is very useful information for me as an instructor to see what's going on, to know something about the dynamics of a team. But generally, particularly for an early assignment, I'd be totally happy to see that everybody's done something, everybody's contributed as it goes. Second team, same thing, everybody's contributed, that's great. The last team, maybe I'm now a little bit worried. Only one of the 4 people on that team had any commits. So maybe I need to intervene, maybe I need to do something about that. But maybe I don't, because often what happens with the students is we have lab sessions where they work on this stuff together in person. Often they'll cluster around one laptop and that one person will type. It's sort of like pair programming with 4 people. And they're the only one who commits because they're the only one who's typing. In that case, it might be totally okay because that's how it worked. Or it might be problematic because maybe Hugo went off and did it all on his own and didn't talk to anybody. So this information is not perfect. It doesn't give you perfect insight in terms of what's going on, but it does help flag potential issues. And so we use both that information as well as peer evaluations at the end of each assignment to say, how much did you contribute? How much did your peers contribute? Were there any problems? Were there any things you want us to know? And that lets us intervene then to say, okay, you didn't commit at all and your teammates said you didn't do anything. Why not? What went wrong? Why are you having trouble? Do you need help knowing how to use Git? did something come up, or did you just flake on this particular assignment, and then we need to penalize your score or something like that. So you get lots of options there. But I would say I would not advocate for using only one or the other. Both these two sources of information give very useful insights in terms of what's going on with the dynamics. Another big thing is automated feedback. So we used to do this with other tools. Now GitHub has GitHub Actions. So for every single assignment we give students, we also build in a GitHub action that gives them feedback. And this is not about automatic grading, although you absolutely could do that. We usually use this for automated feedback about reproducibility. So we have certain requirements about how the repository needs to be organized, and we want to be able to render the document. We don't let them commit the rendered version of it. And so we want to be able to run through it. So in this case, this is an example where a check failed, now it's working, they're finished. And so we tell them that this is a necessary but not sufficient condition to turn in their work. So to dig into it a little bit deeper, there's two linked actions here. The first checks for the allowed files to see you only have the files we want you to have. And the second one then just tries to render the document by running it through our markdown. If we were able to run it and knit it, maybe your answer is wrong, but at least it's reproducibly wrong in terms of what happens. So in this case, this one is failing when it's trying to render. You can then click into these things and get a little bit more information. So in this particular case, this one that I'm showing you failed on the check files thing because you have a disallowed file and it's telling you explicitly bad underscore file is there. Please remove the file. So telling you what to do to correct the process. So we generally try to give informative error messages to tell people what to do and how to fix it. Not to get too into the weeds, this is what it looks like. GitHub Actions are governed by these YAML files. They have their own specific syntax and the rest. This is where this other package checklist comes in. So basically, we're just running this stuff essentially in the cloud on Azure. So the checklist package gives you sort of user-friendly functions to do common checking tasks around looking at these assignments. So this check allowed files, I tell it which files the student is allowed to have. If those are there, it's fine. If it finds anything else, it will fail and then give that error message about that we just saw with the bad file. There's a couple gotchas here I won't get into the weeds on. You get 200 minutes of free time from GitHub to do this kind of stuff. For a large class, you can burn through that in a week. So we also do self-hosted runners. I just have a virtual machine with like 4 cores that does this for both my classes. It's totally fine. It's not a very heavy compute task, but you do need to run through the hoops to set that up ahead of time. And if people are interested, I'm happy to chat about that offline later on. And all of this is also running through Docker containers, which is another whole rabbit hole to go down. But particularly if you're doing stuff in the R ecosystem, there's the Rocker project. There's a bunch of pre-built packages that have all of the hard stuff set up for you. You just have to add some extra code to install the packages you need and then run it, and it's fine. And that's a great thing. So I have ones customized for my class, but they're really 99.9% Rocker with a couple extra packages on top to go through that. Other things, again, another GH class thing, we can grab action status so we can see whether things are succeeding or failing. Again, it's easy to go to the website. We use badges to show that to the students, but for me as an instructor to get insight in terms of did it pass or not, easily to go out, pull that down, check across a bunch of repos to see what's going on. Very recently, one of the other things that we started playing with is artifacts. So one of the other things you can do with actions is, since we're already rendering their document anyway, we can then save that rendered version of the document on GitHub and then access it after the fact. So in this case, when their stuff builds, we're also creating their HTML file that's rendered from our markdown, and we're saving it. And once we've saved it, I can now go out and grab it quickly. So this is not currently in the release version of GH class, but it will be in the next version that's coming out very soon. And so if I have these artifacts, I can go out and download them all very quickly. So for my grading purposes, since they're using the actions anyway, all the students do that. It's all working. I grab all of the artifacts at the end, distribute them to my TAs, and that's what they grade. So it saves me a bunch of time of running stuff locally. And I can still be persnickety about telling them that you're not allowed to commit the HTML file because I want to verify that everything is reproducible fully across the board. The last one I'll mention is this Parse Rmd package. I haven't been doing it as much recently this year. I did a lot more last year. So this is a tool for parsing our markdown files. They're a structured document. So in this case, we can infer structure from it. The reason I mentioned that is because I want to make sure that when students turn in the document, not only is it reproducible, but is the structure correct for what I wanted, that I can then pull the particular pieces out. And this then feeds into that automatic feedback, automatic grading kind of thing. So this is just an example of parsing that homework1.rmd file to check the various bits are in various structures. One use case that I've been playing with so far is around templating. So I can set up a template that says your submission has to match this particular format. And this is just a particular data frame structure that we can put together. And I can then do an automated check that compares your submission versus that. And it will then complain at you saying, you're supposed to have this and you don't, or you're supposed to put an answer here, but you left the default text there, that kind of thing. And this can check for both code chunks as well as text for write-ups and that kind of stuff. The last thing I'll say is about the Python ecosystem. So I'm teaching a Python course. A lot of this has been very R-focused so far, which is great. Turns out all of this stuff is very easily adaptable to Python as well, particularly if you can leverage Quarto. So for my Python course, this is the exact same action that I'm using. The only thing that's different here when I'm checking whether it renders or not is that I'm using Quarto to do that rendering. I've done this in the past with ND convert. That was a little bit fragile. I wouldn't have necessarily recommended it. Quarto is fantastic for doing this. You can render it to HTML, render it to PDF, create an artifact, download it, do all of this stuff. And doesn't matter whether it's an RMD file or an IPython notebook, all of it just sort of magically works. So I would encourage people to play around with this kind of stuff, even if you're not in the R space. And yeah, again, same thing with in terms of uploading that artifact so that I can get access to it and grab it with GH class after the fact. That's it. I'll save a couple minutes for questions or anything else. So my contact information, websites are there, and then a couple papers recently about using Git in the classroom and some other infrastructure comments about using RStudio and Git and GitHub for teaching this kind of stuff. Thank you.
Thanks very much, Colin. This is fantastic. Are there any comments or questions? Debbie?
Yeah, I was wondering, thanks, Colin. I have so many now, like great ideas for the next time I teach this. Do you have plans to take the Parse Rmd package and make it used for grading so that maybe you just extract the answer, and use that for distribution? Yeah,
so that's ultimately the goal, to do that kind of stuff. Like my original reason I put it together was because I was using Gradescope with PDF files, and I have conflicts with how they structure things. And so I needed PDFs with the same, each section of the document was the same length. And so I would use Parse Rmd to split these things up, render them in pieces, then glue the PDFs back together. I would not recommend anybody do this in practice, but that was that basic idea. But the same thing, you could use it definitely now to pull individual pieces out, which you could then run through an automatic checker. So my goal is I don't want my entire assignment to be automatically gradable because I want things to be a bit more open-ended, but I certainly have some questions that could be. And so Parse Rmd, yes, is absolutely about pulling out those pieces, running the automatic checking, saving that result, and then putting it together. The glue is the hard part. I haven't done all of that, and that's something I definitely want to work towards in the near future.
Are you planning to integrate it with GradeThis or any of the R packages for grading?
That would be really nice. Yes, absolutely. That I would like to tie it in there, but I don't use GradeThis enough to know how to do that yet, but it's on the agenda, certainly.
Cool, thank you.
Are there any other comments or questions? I'm just jealous that you've got that working at Duke, and I just want that. I just want this at Toronto. We're so far behind. What's the first sort of step? Like what's one thing that I could implement tomorrow or tonight or whatever? What's the easiest on ramp?
I think playing with some of the action stuff is probably, it's not the easiest on ramp, but I think that's one of the things that gives you the most return. And again, you could make it as complicated or not as you want, but I think we definitely saw major gains in terms of, it's not complicated checking, it's just very basic feedback of, I tried to knit your document and it didn't work. The first time I taught this course, we were not doing this, and it would be like, we want to enforce reproducibility, but they changed one tiny thing that was not a big deal. And I could fix it in 10 seconds and then go on with my life and it's fine. But then they don't get the opportunity to learn that. And that's what this feedback loop about the automatic feedback does, is that they see that there's a problem, they learn how to fix it, and they go on. And that's the biggest gain that I've gotten out of it. And again, you could do much more complicated stuff, but even just that basic, does it render or not kind of thing is fairly straightforward. And that's certainly something that you could do in a lot of, there's other stuff, particularly around our package development, where other people put the actions together and you can just take their existing YAML file, do a couple modifications to it, and it should just work.
Michael Moons. Michael, do you want me to read out yours? Or? Let's read Michael's out. So Michael says, can the checklist actions run on CI continuous integration systems other than GitHub Actions? Michael's not worked with GitHub Actions before.
Yeah, absolutely. There's nothing that ties them particularly to GitHub Actions. They're just generic, sort of mostly like file system interactions. So it mainly leverages that. There's also some stuff around like Rm to do package installs, because that's another common source of issues of a student used a package that I didn't think to include, and we need to install it. So it does all of that. And the RStudio package manager stuff with pre-built binaries helps a lot there. But no, you absolutely, as long as you have like an R system in your CI process, and you can install that checklist package. Currently, it's only on GitHub, but it's working. So you should just install it there. And yeah, it all should be fine. It's nothing particularly unique to GitHub Actions in terms of what it's running with. And it definitely goes for that or anything else. If you're playing with this stuff and you get stuck or have questions, by all means, reach out. I'm happy to help troubleshoot. I'm very interested to see what people develop in this space and collaborating on this kind of thing. A lot of it is me scratching my own itches. So if something doesn't work, let me know, or if there's a feature you'd want, that kind of thing, let me know. But I'm also just curious what people can do and where it will go.
Also, Michael, you need to start using GitHub Actions. I'll talk to your supervisor. By way of background, Michael's supervisor is my wife. And so on that note,